Thank you, Don. Greetings, everyone. We're grateful to be here and excited to share our thoughts on managing configuration sprawl in the modern cloud era. Matt and I are the co-founders of a new configuration management project, and we're starting to talk publicly about what we're working on. At the core of our plans is addressing a pain point we hear over and over, which is configuration is becoming distributed and decentralized, and what that means to managing cloud systems where reliability and security are the utmost priority. Wanted to set some context for the talk and then hand it over the microphone to Matt to walk us through his thinking. So Matt's a thought leader in configuration management. He's worked in the past with Terraform since the very beginning and created his own open source configuration management tools. To give context for this discussion, we're combining our original thinking along with the results of a survey we did of over 200 cloud technology leaders to learn best practices. We tested different concepts and fine-tuned our thinking for a new cloud configuration idea. I'm privileged to introduce my friend and co-founder, Matt Conway, to walk us through his thinking about next generation configuration management.
Thanks, Greg. I'm sure many people here have been in startup land or even worked on new initiatives at, new companies. And, a pattern that you see over and over again is that, when you're first starting out, you have a monolith, especially in startup land where, it's all about figuring out what your product is and what it's going to do. Starting with a monolith helps you get there the quickest. And even in a big organization where you have a lot of, let's call it overhead to getting anything new out, sometimes it's beneficial to go off and do your own little skunk works as a monolith in order to at least prove out, what it is you're working on. So in the beginning, there's a monolith. Everything's good. It's all there in your head. There are many good reasons for starting with a monolith, right? I mean, you think about it, there's less work involved, right? You only have to set up one CI system. You only have to monitor one system or check the logs for one system. You don't have to worry about, where do I go to change that thing? Because it's all right there. Especially if you have a small team, right? You don't have to worry as much about coordinating changes across many team members. They can all just jump in and make those cross-cutting changes that, you tend to have at the early stage, right? You're not, to be honest, more often than not, you have no idea what you're building. You're building something and it's going to change a lot. You're going to make these massive changes, cross-cutting changes, decide to do something one way versus another. And that's really hard to do when you have a distributed system. But it's much easier to do when, you have that monolith. It basically just helps you contain that cognitive load of not just the product, but the system as well, and lets you focus more on the product as you build it. So, I strongly encourage people that are trying to figure out what their product is to don't spend a lot of time trying to figure out the architecture at the same time. Start with a monolith, get your product sorted out. Everything's easier without scale, right? Not just scale in terms of the number of people hitting your site, but scale in terms of the number of people working on it, or the scale in terms of the complexity of the product itself. It's pretty easy to write out business logic. Code is pretty straightforward when it's a single thread of execution, so to speak. Focus on figuring out what your product is before you start worrying about scale. However, time moves on, right? So it can't always be that way. Eventually you reach a stage where it just can't all fit in your head anymore, right? Or fit in the head of all your team members. And then there's a need to, kind of start dealing with the problem of there's all this complexity in your product. How do you make that simpler and more bite-sized for people to deal with? You also run into performance scale problems, right? You've built this monolith to do, X, Y, Z, and it's doing it correctly. It's just not doing it fast. And how do you make it faster? And then, finally, there's the, dealing with the team scale, right? What works for a couple of people does not work for a couple of hundred people. How do you get people to work on the things that matter to them in a way that, coordinates with other people and is complementary, not at odds with each other. And, so, eventually at some point you're going to take this monolith and you're going to break it up. And how you break it up, there's many ways, many things written and said about the best way to go about doing that. That's up to you. It's highly dependent on your team and your system. I don't want to sort of prescribe anything on that front. But basically you want to make it so that the pieces you're breaking things up with are, digestible, maintainable, understandable chunks. And hopefully you're not ending up with this, monolithic set of services instead of just a monolithic app, right? You don't want to end up with 50 monoliths as a replacement for your single monolith. You actually want to break it up in a way that's more, more easy to distribute the work amongst the organization. So then, the most sort of common way to deal with breaking up a system is to try and think of it in terms of how do I decouple the parts of my system from each other. So that can happen on a number of different fronts, right? At the very least, on the product side, you're breaking up this monolithic system because it no longer really fits in your head or the head of anybody else at any one time. So you want to reduce the cognitive load for understanding a piece of the system that you're currently working on, away from the rest of the system, so that you don't have to understand the whole system just to work on your piece, right? And that's what I mean by breaking up cognitive load, right? You're making it, there's a potential impact to every single change that you make to a system. And if there are clear boundaries between the components of a system, then you don't have to worry about all the potential impacts to the rest of the system. You just have to worry about the impacts to the piece that you're currently working on. Decoupling also helps with things like independent iteration. Feature X is the new hotness. So let's go. Let's get it out there, scale it up, ramp it up, make everybody happy to use feature X. But don't break feature Y because that's the only one people are paying for this for, right? So you want to be able to iterate independently on those kinds of things, right? You assign teams to work on X, but you basically have A in maintenance mode, or your changes to X hopefully are not impacting A. Obviously, if you go and make sweeping infrastructure changes or sweeping security changes or something like that, there could be an impact there. But those are more of a class of cross-cutting concerns rather than, for my slice of the system that I'm iterating on, I want to be able to do so in a way that has the least impact on the rest of the system. And then, obviously, when most people think about scaling, they're thinking actually performance scaling, not so much cognitive or team scale. They're worried more about, all right, how do I get more eyeballs on my site? And, by decoupling things from each other, it assists you on that front as well. Feature X may be super popular and it's scaling gangbusters. I'm not having any problem with it. Feature Y is really difficult to scale because it does these complex business logic calculations across a whole bunch of data. So you don't necessarily want them to scale in lockstep. You want to be able to split them apart and say, all right, let's juice up the power on X, but Y, we can only juice it up so much because we'll need to change our database architecture before it can change more. So, typically decoupling helps you deal with that level of scaling as well. So, the goal here is to separate all these threads of execution and understanding, so that overall your system is more stable, your system is more maintainable. People can work on it without butting heads all the time, and you end up with this large decentralized decoupled system. So great, problem solved, right? Yeah, that would be great. It never fails that in software you solve one problem and you end up with 5 more. So even though the class of problems decentralization is solving is it's great, right? And it is actually solving problems by doing things this way. It does introduce a number of other problems. I remember, back at the start of my career, frequently I'd jump in at a company and I'd think, wow, okay, there's a lot of stuff here, right? This piece that I'm working on, it's all okay, and it's pretty easy, and I can work on it great, no problems. But the rest of this shit's just way too complicated. How does anybody manage all this stuff, right? And you know, you have this big picture effect of even though things are decoupled, where you have this ever expanding set of components that work independently from each other. Now there's more moving parts, so there's more complexity there by necessity in order to ensure that those parts all work together seamlessly. And I like to think of this problem as the system is sort of greater than the whole is greater than the sum of its parts, right? So you have all these parts, these components that make up your system. But how do you manage the system itself, right? How do you treat it as an entity that needs to be iterated on and given tender loving care, and you make sure that the system works, not just the set of disconnected components. They may all work, but your system may not work, right? So symptoms of people not thinking enough about the system, at least at reasonably large scale. You end up with downtime or security events of some sort or the other. You can end up with a problem that you're trying to perform forensics on, and you just can't figure out why my system is down, what change caused it. It just makes it very difficult to trace back and find the root cause of the problem that you may be having. And if you have those, very frequently, then it's a tough situation to be in, right? Because you're afraid to make changes because every time you make a change, something breaks, but you can't fix things systematically because you can't make any changes. So there's this situation where you've got this implicit system which most orbs don't treat explicitly as an independent entity, which I think is a mistake there, right? So the hope is that you can start treating the system as its own thing, and hopefully catch a class of errors. Now, a lot of people will throw tech at the problem. So, and sometimes that helps, or it could help in the short term at any rate. I'm sure everybody here that's done anything with Terraform and serverless has been in a situation where they've tried to integrate a serverless component into a beautifully architected IAC system in Terraform and realize that, hey, just because I'm building my infrastructure with Terraform, serverless also wants to build its own infrastructure. How do we get them to coexist and talk to each other and share data and be in the same VPC and talk to the same AWS resources with different IDs? It's tricky, right? The old tech just, it's hard to get tech to integrate with each other, especially as you move up layers in the stack, right? So, you end up with these architecturally layers to your system. Every 5 to 10 years, new tech comes along, and the old tech never goes away. It's still there. You need to get them to play well together. The stuff that you're doing with one set of technology may not work with the new set of technology, even though they're trying to accomplish the same thing, like ensure, your security policies are consistent across these, different technologies. The means for accomplishing that are going to be very different depending on the technology. So it's very tricky to to sort of introduce new tech to solve a problem that is not because of the tech. It's more about how you think of your system as a whole.
Yeah, that's a great point, Matt. Wanted to add in a little bit of the background from our research, where we were fortunate to speak with over 200 cloud technology leaders, DevOps practitioners, perhaps even some folks in this meeting now were part of our study, which we're grateful for their time. And we found this pattern fairly often, which is for projects that have been on the cloud for, say, 3 to 5+ years, there were multiple layers of different tooling that were brought in by different sort of regimes of thinking. And this was adding up to a complexity layer that was starting to become overwhelming. So we heard frequently the concept of configuration sprawl was a task that or a problem that needed to be solved. We learned about multiple examples of different secrets management tools being used by different parts of the org, or different configuration tools. Maybe one team was using CloudFormation, the other is using Terraform. And then we have the legacy tools like Chef, Puppet, and so forth that were also involved in some of the more classic EC2-based architectures. One pattern that we thought was very interesting was that this issue of config sprawl and multiple tools was more pervasive in companies where the DevOps functionality was embedded in mainline software development, as opposed to being managed sort of on an adjacent silo. And there's different schools of thought about what's the right approach, and each company has their own needs around that. But when you had that decentralized DevOps approach, you didn't really have anybody kind of helping to be a coordinator and making decisions that would be most useful for the benefit of the org. It was really what came down to what the team wanted to do. So I thought that was an interesting reveal from our survey, and it helped influence some of our thinking around what we're trying to do with Cloud Truth. So back to you, Matt.
Yeah, so what I think is a key question here is, you have this system, and it's made up of many components, and there needs to be a level of command and control over the system that's independent from the components, both for to achieve that decoupled nature of a large organization, but it also needs to do so in a systematic way that doesn't step on the needs of the people that are actually working on those components. So, this is sort of your typical DevOps developers tension, right? The DevOps tend to be dealing with more of the cross-cutting concerns of a system. So in some respects, you can think of the DevOps team or DevOps organization as sort of the owner of the system component, while the developers are typically owners of their individual components. You may have like an architectural team, or your CTO who built the whole system or whatnot, who they also kind of own the system, but they tend to be divorced from the day-to-day stuff. So it's definitely more in the realm of the system as its own entity is something that DevOps owns and is responsible for. So if we reframe this question, right, for the DevOps perspective, right, you can kind of think of it, there's sort of three aspects to this, right? The DevOps, as I mentioned, cuts across concerns. So security and compliance policies, and then enforcing those across all your components. What are your automation tools, and how are you being efficient as an organization in deploying and testing and delivering the software you're writing? How do you monitor to ensure uptime and performance? How do you ensure consistency at scale, right? Not just consistency of tools, but consistency of these components all. We can ensure that these components are all working correctly, right? Because we know where to look to figure that out. If you have a very heterogeneous environment, that can be difficult. And then the developer concerns, are focused more on the specifics of getting the product out, right? So they care about iteration speed, right? Being able to deliver new features in a efficient and quality way, right? And they want to reduce cognitive load. They're spending all their time thinking about solving problems that are specific to their components, and it's very hard to context switch as a developer. So you're focused on solving my problem, and to have to step out and say, all right, how does Terraform work again, so that I can put this little doohickey in here to ensure my service, is published on this DNS entry, right? They don't want to have to deal with that, right? They'd rather have a way to communicate with ops, and so that they can declare what it is they need, and the ops tooling or the ops team will make that happen, right? So that's how reducing cognitive load could help them. It's tricky, right? Because in a small monolithic world, you get full stack engineers that'll do everything. But as the team grows up and everything, people tend to want to focus on their thing, and developers are certainly more focused on writing the code, making sure the product works and does what it's supposed to do, and don't want to have to go and learn this whole way of deploying things or dealing with AWS or Google or Azure or whatever it is. They want to be able to just push their repo and the system takes care of it. So there's some tension there, right? There's tools and techniques that work for DevOps, but not dev, and vice versa, right? So, I've heard many times where, DevOps spent months and months sort of building this perfect system for ensuring that everything worked great from an ops perspective, and development absolutely hated it and couldn't work with it. And, they had to revert a lot of stuff. I've heard the reverse too, which, tends to be more of a, developers are happy they can get stuff out quickly, but the system isn't particularly robust to change. So every time we, make a meaningful change, there's too many problems that DevOps kind of has to scurry to deal with. So a little bit of a tug of war there. There's, I don't know, every org is different, so there's no specific solution, but, there is certainly tension there. So some solutions in the wild, I think, the first step obviously is to be aware there's a problem, right? You have a system, treat it as its own thing. Don't just assume that it will work implicitly. Then, larger orgs, next slide, Greg. Greg, next slide.
I am advancing. Yep.
Oh, okay, I see it now. Sorry.
Okay.
My bad. So
I can go back.
Right. So larger organizations try and enforce a common way of doing things. Trying to make things homogeneous. That can help with this class of problems. It's hard to enforce though, right? It kind of deprives teams of things that might benefit them. The goal there is more a question of slowing things down in the hope that the extra eyeballs pick up the issues of changes to the system. And it's typically manifested with having things like a change control board or an architecture board or something like that. So it's a very manual process-oriented system. We can probably do better. Another solution, single source of truth, right? We just have Terraform do everything, and that works for a while. It helps you sort of your system is then in Terraform. That is your system component. The problem there is that it's hard to get Terraform to do everything all the time. It starts breaking down when you try and use it for deploys, and there's different SaaS apps it may not work with, and you can end up using the wrong tool for some jobs to accomplish better coverage of your system. You never really get all the way there. And then, a third option is, what we think of as kind of configuration Legos. So view of the system, functional view of the system, everything has inputs and outputs. They have configuration signatures. That's, kind of where dev would indicate to ops, how my component fits into the rest of the system. And, you connect the dots and map the system out and have a good picture of how it all fits together and flows together. And, no surprise here, but this is what CloudTruth is trying to accomplish. Trying to give people from at least the configuration layer a way to manage their system and have an understanding of the state of their system at any time. We think there's promise here. We're a startup. We're trying to figure it out as we go. So happy to hear feedback, and hopefully somebody can see some value there.
Thanks, Matt. It's been great to have you walk us through our thinking and how we've evolved from the beginning days of the project to where we are right now. A shameless plug, we're looking for further feedback on this configuration intelligence concept. Head over to cloudtruth.com and let us know your thoughts. You can sign up for a private beta or sign up for more information. So thanks again to the DevOps Day Boston folks for inviting us to talk about this topic that we're so interested in.
Of course, Greg and Matt, thank you guys for presenting. Really appreciate it. Great talk. This is honestly, I think, a problem that everyone in this audience probably has in some way, shape, or form. So it's good to hear that there are solutions. Let's jump into Q&A. And again, for everybody participating in the audience, feel free to add your questions to the stage chat, and I will read them. I'll read them live here as they come in. Let's just start off with, you started off talking a little bit about, there are organizations which have teams which sort of don't have DevOps as a central function, and we end up, as a result, having teams that completely own their configuration and teams that want nothing to do with their configuration, and it just sort of happens as a side effect. How do we handle those two types of teams?
Matt, you want to take that? Yeah.
Sure. That's a great question, right? So there's a couple different ways that we've seen DevOps implemented, right? There's the ones where you have a dedicated DevOps team that it's like a matrix employee that kind of fit on all the teams. And then you have people that actually embed DevOps members on the teams that work in the day-to-day with the team. Now, if a team wants to be able to contribute as much as possible to the DevOps, that's great. But at the same time, as you say, you have to help the teams that don't have the DevOps members as well, right? And it's tricky because you want some kind of consistency across those teams, right? You don't want a half-assed effort on one team and an over-engineered effort on the other team. So spread the love, I guess, is probably the only way you can deal with that. Making sure that the people that are DevOps focused have some kind of input on all the teams, and for the teams that just don't want to deal with it at all, there has to be a way for you to to encourage that communication of being able to express the needs of your components such that DevOps can fulfill them for you. So there's a communication burden there. Different teams deal with it differently. You can deal with it with just kind of ticketing system of some sort. But it's much better if you have a formal way of describing the dependencies between the components in your system. So this is what we think of as that configuration signature, right? If every component has a way of defining what it needs from a configuration perspective, then that can be decoupled from the people that are actually supplying that configuration.
Got it. Can you talk a little bit more about the configuration signature? What does it really mean to have a configuration signature?
So a lot of components have that already implicitly, but it may be as simple as the .env file that controls the behavior of your component, right? And if it's implicit, it could even just be in the code, right? The code is just looking for this configuration in the end, even if you haven't specified what all the possibilities are. So a configuration signature would be a formal way of a component declaring, hey, this is what I need to operate, and these are the valid values you can give me to change that operation. So if you kind of think about it, like if you think about back in the days of C++ or C, you had a header file and you had an implementation file, and the header is basically a collection of function signatures, which is this function takes these parameters and gives this result. You can kind of think of it that way for a component, say a container. These are all of the environment variables you can supply me, and these are the kinds of values they take, and this is how it will impact the behavior of my component. And being able to formalize that in such a way that automation can take care of exposing that to that centralized team that deals with these cross-cutting concerns. So developers don't focus as much on managing the DevOpsy aspects of the system. They're just saying, hey, set these values and my component will work. And then the DevOps and the tools they're using will expose that to the right people and ensure that they get set.
Got it. So the idea is that instead of saying this is my configuration, I say my application needs these things to be configured, and then maybe we can go fetch those out of a parameter store or something like that. Would that be a useful use case there?
Absolutely, yeah. Obviously there's understanding there. You don't want to just arbitrarily give it random values, right? It has to be values that make sense to the component. But certainly, a parameter store is one way to be that clearinghouse of system configuration across all your components.
Got it. Can you get a little bit into what happens when we don't use a system like that? Do we end up with, configuration sprawl? I think you used the term desynchronization. Can you give me some examples of those?
Yeah, so desync would be something like 6 out of 10 of your components in your system need this parameter set, and you only set it for 3 of them because you didn't realize the other 3 needed it, right? And then you end up with this kind of split behavior in your system where some things are using the right parameter and some things aren't, and your configuration has effectively become desynchronized across those components for that particular parameter. Configuration sprawl is basically, you want to make a change and you have to go make it in 10 places. Either the same change, like we just discussed with the desync problem, or you're making a change that infects multiple systems across multiple parameters, but all those things are not set in one place. So you have to kind of go hunt down all the places you want to change this thing. You have to be able to realize that if I'm changing, parameter X to change the behavior, I may also have to change secret Y, and things along of that nature, right? So, if all that stuff is kind of decentralized and spread out all over the place, it makes it very hard to make changes to your system.
Right. Something interesting you brought up is that values that you put in your config have to make sense for the application. And where configuration becomes decentralized, especially as we break off the monolith into more and more small pieces, we might say still have a monolithic data layer while we have a service-based set of applications. So what are some ways we can maybe enforce policy across those applications? Like, let's say that we know that we want to make sure that we have TLS enabled on all of our database connections. What are some ways that we can enforce that we're doing that?
Right. So, it comes down a lot to the tools you're using, but there also has to be a consistent way of defining those cross-cutting concerns, right? So, if in the case of setting TLS on your database connection, that's going to be very specific to your provider, right? So that has to be something that you, as an organization, choose to address in your infrastructure as code source, right? However, once you have chosen to address that across all of the things that need that addressed, you can extract out, to some extent, the parameters that control that behavior, and then expose that as a system level variable that can impact multiple systems. But yeah, there is a certain amount of overhead involved with you as a DevOps team going through and having these patterns in your infrastructure code that you can control, either at a low enough level of granularity that you care about, or across as many systems as you care about. So there's no silver bullet there. It's just hard work, right?
Got it.
Setting up your code to do the right thing, and then possibly extracting out those parameters so that you can control them easily without having to understand how it all fits together. Right.
Got it. Well, that's all we have time for with questions, but if anyone feels like asking more, we are going to be starting a breakout on decentralized configuration management. That will be starting in the Sessions tab in Hopin. Up next, we have Kat Cosgrove with Updating the Edge. If you'd like to tune in for that, stay here on the main stage. And if you'd like to talk more with Greg and Matt, feel free to head on over to the breakout. And Greg and Matt, thank you very much for coming.
Thank you.